All right, today we're going to do the inverse of a matrix. We're really just going to do 2 by 2s by hand. So if I have a matrix that's a 2 by 2, it's going to be A, B, C, and D. The first thing I have to do is I have to find the determinant. The determinant of this guy is equal to A times D minus B times C. So I'm going to do that. And then I'm going to put 1 over the determinant times, to get the inverse, what we need to do is we need to switch these guys right here, D and A, and we need to switch the sign of these guys right here. So when I distribute this, it's going to give me the inverse. So the inverse of a matrix is really D over the determinant, negative B over the determinant, negative C over the determinant, and A over the determinant. And this is your final inverse answer. So what I'm going to do is I'm going to do a couple of examples. Here's the first one. 1, 2, 3, 4. First thing I do is I find the determinant, which is 1 times 4 minus 3 times 2, which gives me 4 minus 6, which is negative 2. Okay, so just like it says right here, I have to do 1 over that, 1 over negative 2, times, and some stuff's going to move around. These guys are going to switch positions. These guys are going to switch signs. Then I'm going to distribute this negative 1/2 to everything in here. So negative 1/2 times 4 is negative 2. Negative 1/2 times negative 2 is 1. Negative 1/2 times negative 3 is 3 over 2. And negative 1/2 times 1 is negative 1/2. And this is the inverse. And it's really just, that's all that you're doing. I'll do a couple more examples just to reiterate the fact. So 5, 7, negative 6, and 11. First thing I'm going to do is I'm going to find the determinant, which is going to be 5 times 11 minus 7 times negative 6. Minus a negative becomes positive. Which gives me 97. So I'm going to do 1 over 97 times, these guys switch positions, these guys switch signs. And then I want to distribute, so I'm going to have 11 over 97, negative 7 over 97, 6 over 97, and 5 over 97. I'm pretty sure I can't simplify any of those fractions, so that's my answer. And that's really all you're doing on determinants. Inverses. That's all that you're doing, okay? Sometimes they'll ask you if one matrix is the inverse of another matrix. Like they'll say, is this the inverse of Now obviously I just did this problem, so I know that they're the inverses. But what I can do is I can either find the inverse of this matrix and see if it is this one, or I can multiply the two together. When you multiply two inverses together, you should get the identity matrix. So I'm going to do that. I'm going to multiply these two together. So I'm going to multiply right here. So I'm going to do this row times this column gives me my first spot. 5 times 11 over 97 plus 7 times 6 over 97. This row times this column gives me my second spot. 5 times negative 7 over 97 plus 7 times 5 over 97. This row times this column gives me my next spot. Negative 6 times 11 over 97 plus 11 times 6 over 97. This row times this column gives me my last spot. Negative 6 times negative 7 over 97 plus 11 times 5 over 97. And I'm looking for the identity matrix. So I'm going to simplify this out. This is 55 over 97 plus 42 over 97. 55 plus 42 is 97 over 97, which is 1. This guy is going to give me negative 35 over 97 plus 35 over 97. Negative 35 plus 35 is 0. This is going to give me negative 66 over 97 plus 66 over 97. Negative 66 plus 66 is 0. This is going to give me positive 42 over 97. This is going to give me 55 over 97. So 42 plus 55 is 97 over 97, which is 1. So it did give me the identity matrix, so the answer is yes. Though these two are inverses of each other. And that's it. That's all that you're doing. Now, if you have a 3x3 matrix, you have a handy tool that's going to help you to do it. I can show you guys how to do it, but it's going to take you a real long time. So we're not going to worry about doing those. When we want to do the inverse of a 3x3, we're going to plug it into the calculator. So we're going to go into the matrix and we're going to edit matrix A. We're going to make it a 3x3 or any sort of dimensions really we're going to do on here. So let's say that our matrix is this guy right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it wants us to find the inverse. We're going to plug it into the calculator. 1, 4, 7, 2, 5, 8, 3, 6, 9. Then we're going to quit. We're going to go back in, select matrix A, put to the power of -1. And it's going to say that there's an error, meaning that there is not an inverse of this matrix. So I'm going to change one value. I'm going to change this to 11. And I'm going to go back in. I'm going to go into the matrix and I'm going to edit matrix A. And I'm going to make this 11. Go back to quit, go to matrix, select it, put it to the power of -1. And now it gives me this crazy matrix. I'm going to turn it into fractions. So this is my inverse. And that's all that you're doing. If you have anything that's not a 2x2, you're going to do it on the calculator.